Hey guys, today we're going to do section 2, topics 3 and 4. So we're getting into solving equations. So page 34 in your Algebra Nation books. This first table right here is a nice review over what we did in the last two topics before this. So we're going to remember our properties. So we're going to fill in the table justifying each step below. So my first step is always a given. It's the given equation. So we're going to look what's different between step A and step B. I notice this is the exact same, but this side changed. And it changed by distribution. All right, the 5 got distributed to the x and the 3 to get 5x plus 15 because we multiply when we distribute. All right. Do it again from part B to part C. We look at what's different. This side, the exact same, but over here, if you notice, it goes 2 minus x plus 9 to 2 plus 9 minus x. So if you notice between these two, looks like they switched the negative x and the 9, so they switched the order. Remember, we had two other properties. We had the associative and we had the commutative. Associative is if your grouping got changed, and the commutative was when order was changed. So here they changed the order of things being written. So this was our commutative property. All right, part D is an equivalent equation. They actually combined like terms. They just did 2 plus 9 to get 11. All right. From D to E, what is different? Well, it looks like both sides of my equation got a minus 13 put to it, so there was subtraction going on. So they're moving the 11 over to the other side. Not the 11, the 13. Because here, 13 minus 13, see how that cancels? So just 5x is left. And then here, 11 minus 13, that's where negative 2 came from. All right, so there's my equivalent equation after they combine like terms. Then I'm going to go from F to G. And on here, I'm going to notice that there's a plus x on both sides, so we did some addition. Here, minus x plus x, that cancels. 5x plus x gives me 6x, so that's the equivalent equation below. Then from H to I, they are dividing by 6 on both sides, so this is division. And then we have our equivalent equation. Once they do divide, we get x equals negative 2 over 6 simplifies to negative 1/3. So that's a good summary of the first two topics together. We're going to keep going with something like this. Okay, we're just going to do it with word problems. Now, we're going to mix together what we did in our last two topics and what you did in the very, very first topic of this book, which was writing expressions. Okay, now we're just going to see them in the format of a word problem. So the class is raising funds to go ice skating at the rink at Campus Martius in Detroit. The class plans to rent one bus. It costs $150 to rent a bus for the day, plus $11 per student for admission to the rink, including skates. What is the variable in the situation? All right, so the variable is the piece we don't know. All right, so I look at what am I spending money on? We're spending money on a bus, right? $150 for a bus, and we're spending money on students to skate. I already know we're going to get one bus. That's known. What I don't know is how many students there's going to be. So we're going to say x equals number of students. Write an expression to represent the amount of money the school needs to raise. All right, so the total money that they needs to cover the bus, which we already know is $150, right? It's going to be the bus plus admission for students, right? So I know that my bus is $150. Admission for students, I don't know how many students there are, but I do know it's $11 per student. So it's going to be 11x. So the total money is going to equal $150 plus 11x. The class raised $500 for the trip. Write an equation to represent the number of students who can attend the trip. So this is the total amount of money that was raised. So my total amount is here now. It's going to equal $150 for the bus plus $11 per kid for the skating rink. Solve the equation to determine the number of students who can attend the trip. So we're going to solve for x. Okay, so I'm going to write my given equation. Now we're going to start moving things over. Remember, we want to get the x by itself. Right now I have 150 being added to it, so I'm going to subtract 150 to the other side. 150 minus 150, that gives me 0, that's why it cancels. 500 minus 150 gives me 350. That will equal 11x. Then we still have something attached to my x. It's the number 11 and it's being multiplied. So to undo that, we will divide. Because 11 divided by 11 is 1. So this leaves me with 1x. And 350 divided by 11 equals 31.8. Okay, so we have enough money to take 31.8 students. Now, I can't take 0.8 students, right? I cannot round this, though, to 32. I don't have enough money for 32 students, right? I have enough money for 31.8. And if I can't take 0.8 of a student, then we only have enough money for 31 students. So we have enough money for 31 students. Okay, again, I cannot round up because I don't have enough money for 32. 32 students would cost too much. It would cost more than $500. I don't have that money. I only have 500. All right, consider the equation 2x minus 3 times 2x minus 1 equals 3 minus 4x. Solve the equation for x. For each step, identify the property used to write the equivalent equation. Okay, so first thing we always do is write what they give us. So I have 2x minus 3, 2x minus 1 is going to equal 3 minus 4x. That's always my given. All right. Oops, sorry, dropped the pen. All right, part B is going to be what is the next step. So the next thing we're going to do, I'm going to take -3 and I'm going to distribute. So part B, I'm going to distribute. So 2x is still here. -3 times 2x is -6x. -3 times -1 gives me +3. All right. Step C, I noticed that I have two x's together right here, so I'm going to go ahead and combine like terms. 2 minus 6 is equal to -4. So -4x plus 3 equals 3 minus 4x. This is an equivalent equation because all I did was combine like terms. Equivalent, come on. Equivalent equation. All right, I'm going to go ahead and rearrange the second equation so it's in the same order as my first one, so an x and then the number. So I'm going to keep this -4 x plus 3. I'm going to rearrange this. So -4x is going to be first and then plus 3. So what I did was I changed the order. So this is the commutative property. All right, now I'm going to move those 3's over. I'm going to subtract 3 to the other side. So that cancels out. But this one also cancels out, right? So let me rewrite this in the way that they had it before. So part E, we're going to subtract the 3 on both sides. Come on. Okay, so this is subtraction. When I do that, 3 minus 3 is 0, and I notice that it does happen on both sides. See that? 3 minus 3, 3 minus 3. So I'm left with negative 4x equals negative 4x. Okay, this is our equivalent equation again. It's always equivalent equation when you combine like terms. So this is when you combine like terms. All right, so notice something here. This goes back to our last topic. I have 2 equal expressions, don't I? They're the exact same thing. They were also the exact same in part D, so technically I could have recognized it there. Okay, but I do recognize it in part F. They are the exact same equation. So we talked about when we have 2 equal expressions set equal to each other, then that means that our solution is going to be all the values. All values. Can be used for x. So our solution is all values. You can also say an infinite amount of solutions. So infinite. There you go. All right, so because we had equal expressions right here, that's why I can say that. So equal expressions. That's why we can say that there are infinite solutions. They are all going to work. Okay, that is true for every case. Whenever we get an equation where it's equal like that, we get 2 equal things, then we all have all real numbers as the solutions. That's everything. Okay. Another way to show all real numbers is this cool looking R. That means the same thing, all reals. All right. Let's do another one. Here we have 3 times 4x plus 1. Remember, this is our given. 3 times 4x plus 1 is going to equal 3. Oh, plus 12x minus 5. Our first is always a given. All right, after this, let's see here. My first step, I'm going to distribute again. So part B is going to be to distribute. When I distribute, 3 times 4 gives me 12x, and then 3 times 1 gives me 3. This equals 3 plus 12x minus 5. I'm going to combine like terms, but I'm going to rearrange this side first. So what I'm going to do is I'm actually going to switch the 12x and the 3. So that way the 3 and the 5 are next to each other. Remember, I changed the order. So that's going to be the commutative property. All right, and then I am going to combine like terms. So I'm actually going to do 3 minus 5. So I have 12x plus 3 equals 12x. Well, 3 minus 5 is negative 2. So remember, whenever you combine like terms, that's an equivalent equation. I'm just going to abbreviate since my pen is acting up. Equivalent equation. All right, look at this. I have 12x plus 3 equals 12x minus 2. Okay, well, they're set up the same way. They both have 12x, but one's a plus 3 and the other is a minus 2. I have a feeling this is not going to work out for me, but I'm going to keep doing a couple more steps just to make sure. All right, I'm going to subtract this 3 to the other side to give me 12x equals 12x minus 5. So part E I subtracted. And then I'm going to subtract 12x and watch what happens. When I subtract 12x over, okay, so part F, I'm subtracting again. 12x minus 12x gives me 0. 12x minus 12x gives me 0. So I get 0 is equal to negative 5. Well, that's not true, is it? That is not a true statement. And I recognize that earlier in part D when I had two not equal expressions. So because my expressions are not equal, because that right here, my F, is a false statement, that means there are no solutions. All right, so there's no solutions to this one. So sometimes we're going to get equations here. They both have a 2x, but this is plus 5, this is negative 1. That means no solution. There's nothing I can plug in for x to make it true. All right, I want you to try this question. Go ahead and pause the video, and you try this. I'll read it first. Brooklyn Technical School High School surveyed its students about their favorite sports. The 487 students who listed soccer as their favorite sport represented 17 fewer students than 3 times the number of students who listed basketball as their favorite sport. Write and solve an equation to determine how many students listed basketball as their favorite sport. All right, so pause and try. All right, check your work with mine. I had to define my variable. My variable, I used x, and that's going to represent the students that like basketball. That's what it wants me to determine. The equation I set up, so 487 students who listed soccer as their favorite sport represented. So that means 487 equals 17 fewer students. So this was one of those tricky words and phrases in our writing expressions section. Okay, less than, fewer than, it means you subtract that number from the end. So 17 fewer means I have to subtract 17 from something. And we're going to do it from 3 times the number of students. So that's where 3x comes from. So 3x minus 17. Then I added 17. I divided by 3. I get 168. And word problems always get word answers. So 168 students like basketball. Good job. All right, you're going to pause again. This is just like the one we started off with in this lesson. So pause and please fill this one out. Remember, you're using your properties. Okay, check your answers with mine. So from part A to part B, they distributed the 2 to the x plus 5 to give us 2x plus 10. From part C to part D, they are subtracting 7 on both sides, so that is subtraction. Then from E to F, they are dividing by 2, so they are dividing. It is division. Did you do good? I bet you did. All right, so we're going to now go on to topic 4. So that was all for topic 3, okay? Topic 4, we're going to talk about using the zero product property to solve equations, okay? So go ahead and turn to page 36, and let's move on to topic 4. If someone told you that the product of two numbers is 10, what could you say about the two numbers? Okay, so that means if I have A times B, that's product, equals 10. What can I say about these numbers? Well, I can say that A and B, they have to be the same sign, right? They have to either both be positive or both be negative. Because, yeah, they could be 2 and 5, 1 and 10, but it could also be -2, -5, and -1, -10, right? So A and B have to be both positive or both negative. Okay. Some vocab here. I'm also going to say that A and B are factors of 10. Okay, so A and B are each a factor of 10. So 1, 2, 5, or 10 is what A and B can equal. All right. If someone told you that the product of two numbers is 0, what can you say about those two numbers? Okay, so now if I have A times B and that gives me 0, what can you say about them? Think about it. Doesn't one of them have to be equal to 0? Or both of them? So at least one factor come on. Oh my gosh. At least one. Oh, I'm so sorry. There we go. At least one factor has to be equal to 0, right? For my product to equal 0, I have to multiply something by 0, right? All right, so that is our 0 product property. If A times B equals 0, then either A equals 0 or B equals 0. Okay, one of the factors has to be equal to 0. Describe how to use the 0 product property to solve the equation x minus 3 times x plus 9 equals 0. Then identify the solutions. So I have two products, or I have two factors, excuse me. I have a factor of x minus 3 and another factor of x plus 9. If multiplying those two factors is equal to 0, then one of them has to be equal to 0. Okay, so I'm going to set each piece equal to 0. So each factor is going to get set equal to 0 because one of them has to be, right? I don't know which one. I'm going to figure out what x value is going to make that happen. So here to get x on its own, we're going to add 3 to each side, and we're going to get x is equal to positive 3. Over here to get x by itself, we're going to subtract 9. And we get x is equal to negative 9. So if x equals 3, that makes this piece 0. If x equals negative 9, that makes this piece 0. So both of these are going to be a solution because either one of them can make this whole thing equal to 0. Okay? Let's do another one. 2x times x plus 4 times x plus 5 equals 0. Well, this time, okay, we have three factors. We have 2x, we have x plus 4, and we have x plus 5. Okay, so we have three different factors this time. So I'm going to set each of them equal to 0. So we have 2x equals 0, we have x plus 4 equals 0, and we have x plus 5 equals 0. Okay, one of them has to be equal to 0 for the whole thing to equal 0, right? We're multiplying. Over here, to solve for my x in the first factor, 2 is being multiplied, so I'm going to divide it from each side. 0 divided by 2 gives me 0. All right, so there's one possible solution. Over here, subtract 4 from both sides, and I'm going to get x is equal to negative 4. That could be a solution. And then last one over here, we have negative 5. This will give me x is equal to negative 5. So this one actually has 3 possible solutions because there were 3 possible places to make it equal to 0. Okay, so however many factors there are with a variable, we should get that many solutions. All right, identify the solutions to this one. 2x minus 5 times x plus 11 equals 0. All right, I have 2 factors here. We have 2x minus 5, make that equal to 0. And then we also have x plus 11, make that equal to 0. I want you to go ahead and pause and solve for x. All right, so for this one, you should have gotten x equals 5 over 2 and x equals negative 11. Good job. All right, Michael was given the equation x plus 7 times x minus 11 equals 0 and asked to find the zeros. His solution set was negative 11, 7. So a solution set means he just listed his x values. So he got x equals negative 11 and 7. Explain whether you agree or disagree with Michael. Okay, so, well, if I set each factor equal to 0, like you're supposed to, okay, that's how you find your zeros. You set it equal to 0, okay. Over here, I'm going to subtract 7. Over here, I'm going to add 11. So I actually get x equals negative 7 and x equals positive 11. That's my solution set. Michael got the opposites, so I'm going to disagree with Michael. Okay? And reason being, he did not set his factors equal to 0. Okay? Did not set factors equal to 0. Okay, he just saw the 7 and the negative 11 and the parentheses and just thought that was the answer. That's wrong. You have to set them equal to 0 and actually solve for x. Okay, notice it was the opposite of what he said. It was positive 11 and negative 7. All right, my next one is identify the solutions to 2 times y minus 3 times 6 times negative y minus 3 equals 0. All right, so this time, if you notice, we actually have 4 different factors. We have 2, we have y minus 3, I have 6, and I have negative y minus 3. So there are 4 different pieces here. They're all being multiplied together. That's how I know they're all factors. I'm going to take each one of those and make them equal to 0. So I'm going to put 2 equal to 0. I'm going to put y minus 3 is equal to 0. 6 equals 0. And negative y minus 3 equals 0. Okay. Well, my very first one, 2 equals 0, that's not even true. And there's no x. So guess what? This can't give me a solution if there's no variable to solve for. Right? So that one's out. Over here, y minus 3 equals 0. I can add 3 to the other side. To get y by itself, we get y equals positive 3. There's one of my solutions. Over here, 6 equals 0. Again, that's a false statement, and there's no variable to solve for, so there is no solution to find in this one. Last one, I am going to add 3 on both sides. Now I have negative y equals 3. Y is not alone yet. There is a negative 1 being multiplied to it. So I'm going to divide both sides by negative 1 to give me y equals negative 3. So this one has 2 different solutions. We have y equals 3 and we have y equals negative 3. Okay, so if I plug those in for y, they will each give me a 0 in the equation somewhere. Good. Last one. All right, I want you to pause. You can do it. All of your answers are in this word bank, okay? These first 3 have 2 different solutions, and then the last 2 have 3 different solutions. You will use each number in the answer bank 1 time. So once you use it, scratch it off so you don't use it again. All right, pause and do it. Alright guys, check your answers with mine. Everything was used once. I got -1/2 and -14. Then I got 2/7 and 4/5. Then I got -3/4 and 6. Then 0, -2, 3. And then 0, -1/4 and 2. And 0 was, it showed up twice in your table, so I was able to use it twice for my answers. So here's all of my work. There's my work for the first couple problems. Color coordinated, of course. And then for my last ones. All right, that's it, guys. You have a worksheet. There are 7 questions. It covers both of these topics, so it's just one worksheet today for all of this. The next time we get together, we're going to review topics 1, 2, 3, and 4, and you're going to take a quiz. All right? So yeah, I will see you next time. Let me know if you have any questions. Bye.